Hi, pre-algebra guys. We are going to start with 9.4 today. So grab your interactive notebook, get your book out to follow along, and we'll jump right in. So this chapter, we learned about relations and functions, and now we're going to look at the most basic of functions, who is continuous, and that would be a linear function. Okay, so a linear function, here's the definition. I want you to take a minute to write this down, and I'll describe it and show you what it should look like. A linear function is some function whose graph is a line. That should say line. This means there are two variables, but it's only to the first power. So you're never going to see an x squared. You'll never see an x to the third power. You'll never see an x in the denominator. So you wouldn't see this. That would be really x to the -1 power, and we want to have just a first power of 1. And it's going to look, when you graph it, it's going to look just like a line. That's the only thing else. It won't curve like some graphs do. Some graphs do things like this. This is going to look like a straight line up. It could be a straight line down. It could be a cross. There are lots of ways, but it's going to be a straight line. And so you're only going to have a y and an x. And they will both be to the power of 1. And this will make more sense as we kind of go along. So just kind of believe me for that, and then let's keep going here a little bit. Okay, so we're going to start seeing our functions written in a couple different ways, and I want to point this out to you. You might see y equals, and then some number, you have an x, or you might have an x and a y on the same side, but we just have two variables, right? And they both have an exponent of 1, which is what it said, so this must be a linear function. Now, we don't see the picture of it with just this equation. We would see that over here, so we don't necessarily know by looking at it that it's a line unless we look to say, okay, two variables, exponent of 1. Okay, now I can identify this to be a line. The other thing that I want to point out to make sure we're going to get to it in this one, okay. Let's see if I put this in here. Okay, it'll come later. I'll show that to you when we get there. Sorry, I'm making you go going fast through the slides. Okay, so let's see. Basically, we have a line, and it's given by this equation here. This is called a function, and this is the equation of the line. This is the rule that it follows, and we'll talk a lot more about this in Algebra 1. We'll spend a couple weeks on this, but this is a good just kind of preview. You guys need to see it and know what's going on. We have some sort of an input that's going to be x, and if you follow the rule, if I input some number here for x, and then I multiply it by 2, and then I add 3, it's going to output some value of y. Okay, so I want us to kind of identify what's happening here, but mostly just be able to look at an equation, know there's two variables, exponent of 1, it's linear, and then we'll be able to kind of go from there. So what I want to know, if this here is this line, is the point -1, 2 a solution to the equation, or is another way to state that is this point on the line? Like if you plug in this value of x and this value of y in your coordinate point, right? We have these as an x and a y. Would it be true, or would it be on that line? If it's not on the line, then it's not a solution. If it is on the line, then it is a solution. So let's plot it. If you come to -1, so you come over to -1 and then go up 2, we're going to kind of plot that point right here. Is that point on the line? Oh, no, it's not. So is this a solution to the equation? No. But you're not always going to have it graphed, so I'm going to show you both ways here. What we can do is we can plug in some of our numbers. Instead of using y, if this is a coordinate point, I can plug in the y and I can plug in the x, and if it makes some statement that is true, then it will be on the line. So let's just try it. It'll make a little more sense here when we just kind of put some things in. Okay, so y was 2. I'm going to just, instead of using y, I'll use that. And instead of x, I'm going to use a -1. So let's kind of work this out here. So does 2 equals -2 plus 3? So 2 equals a 1. Does 2 equal 1? No. So this is not true. It's not on the line, which is what we just said here by plotting that point. Okay, makes sense? All right, let's try it again with another point. It's the same equation as you can see here. Same line, different point. So let's project it. Let's see. 2, come over 2, come up 7. This line is not drawn well. This is what the bad thing about my stylist here is that I'm still learning. I'll teach you guys how to draw these lines so they're accurate. And if you had a straight edge and a ruler at home, you'll have significantly better accuracy. Or actually, if a ruler would work on this, I'll have to try that out later. Okay, let's see. If I have, for y, that's 7, right? It's always x, y is your coordinate point. And here's your x. You guys understanding this? This is the point 2, 7. And I'm going to plot it here. We're going to say, hey, I'm plotting this point. It looks like it's on the line. Now that I made the line look a little bit better. So let's plug them in and try it. 7 equals, remember, both ways work. This way is significantly easier, but there's room for error, as you already saw. And you may not always have it graphed. This way over here, if you don't have the graph, is always accurate and it comes down mathematically, so you're not going to have a margin of error, but it takes a little bit longer. Okay, so there's kind of pros and cons to both ways. We will almost always do it this way here. All right, 2 times, what is x this time? 2. So 7 equals 4 plus 3. 7 equals 7. Is that true? Yes, it is. So is this point on the line? Yes, it is on the line, or yes, it's a solution. Okay? How are we feeling about that? Remember, this one was not on the line, and I had something that was not equal. I should have drawn a line through that. It's not equal. So it's not a solution. And then if it did prove to be true, if this point here made the statement true when you put them in, then, and it's on the line, I guess, we could say that too, then it is a solution. Okay? Alright, why don't you turn to page 364 and try skills check number 1. Try numbers 1 through 4. Please pause the video, try them on your own, and then hit play and we'll go over them together. Okay, how do you do? The function was given with this rule. Y equals 3 times whatever x is and 4 more than that. Okay, so I had some points and we had to plug them in and see if they're true or not true. And I'm not going to go over each single one about how to do it. We're just going to do the first one together. So, oops, this is y. We'll put in the y value for y. 3 times a negative 2, put in the x value here for x, plus 4. Negative 1 equals a negative 6 plus 4. Negative 1 equals negative 2. It does not equal, so the answer to this one is no. The answer to number 2 is yes. So the point 0, 4 lies on the line that is given by this rule. Can you have more than one point on the line? Could we have more than one that's yes? Yeah, you could have an infinite number. It will go on forever and always. Again, only on that line, but because there's arrows, it will go and go and go. All right. So number 3 was also yes, and number 4 was no. If you missed one of those, pause it, go back, kind of try to figure out what you did wrong. Plug them in. Take steps. Remember to multiply before you add or subtract. That might be the problem there. Okay. Let's try a couple more. We're going to start making a table now, okay? So you can have some line in here given by a certain rule, and the rule is going to look a little bit different. This is called function notation. Anytime you see y, you could substitute that for f of x. They are interchangeable. I guess I kind of wrote the exact same thing. Anytime you see y, you could put f of x. Anytime you see f of x, you could cross it out and put y. Okay, they're exactly the same thing. This just means function notation. What does y equal for some value of x? And the reason this is beneficial is because we can pick a point on my line and pick some x value and see what my y value is all the way up and down that line. Okay, so that's kind of the benefit. So let's look at this. I know this looks really confusing and all over the place, but let's just plug through one together and try it out. Side note that I thought of earlier, and I was trying so hard to try to find a way to put a video in this, but I couldn't figure it out. So, and I actually don't think this app that I have has the capabilities of this, but someone sent me this little TikTok that had some guy who was on this side, and it had a Y on this side, and he used like the mirror effect. I don't know if he had an app for that or something. Y'all, I don't know how TikTok works, so you can teach me. And so he was dancing and doing a little, it's hard to draw a stick figure dancing. There we go. So he was dancing, and what he was pointing out was that it's the same. So f of x equals y. It was funny. Anyway, go find it, and then you'll always remember that f of x is the same thing as y. Okay, so what we get to do is we just get to pick whatever values we want. Because remember, a line goes on forever and always. So if a line, it doesn't always have to go up like that. I guess I've been drawing them now. We could go down like this, right? We talked about that. If this is a line on the coordinate plane, so let's kind of draw the coordinate plane. This is your y, this is your x. These go on forever. These are just your axes. Let's say we had some line that came down here. Any value of x you want will have some value of y. So if I'm way down here at x equals negative 20 or something, I could come up and it would eventually be on the line. If I was down here at x equals negative 5, well, if I gave you plugged in x equals negative 5, I could find, look, when I come up like this, it touches the graph. So we know it's a function because remember the straight vertical line test. You'll be able to determine that it's a function. There's not more than one point with any vertical line. And you'll have some value of y. So we can pick any number here. I like to pick numbers that make it easier on you. So we could pick negative 1, we could pick 0, and we could pick 1. And it would just be like this point here, and this point here. Now, this graph in red here is not the same as this rule. I just kind of sketched one real quickly to show you what that would look like. I guess I could draw this actual one on there. It would be way down here and kind of come up this way. Okay. So, if I have f of x, I'm going to write this as f of, now I know what x is, f of negative 1. Well, f of x equals x minus 4. So now I know I'm plugging in that x, right? If this is what x is. This isn't hard in terms of the steps, but the function notation, like writing it out with all this extra stuff, man, it's confusing, isn't it? It's very different than what we've been doing. And then I'm just going to copy the rest of that part of my formula. Okay, so what do I get? That would give me a negative 5. So there is a point on the line where x is 1, and now remember, this is the same as y, and y is negative 5. So I would have this point, right? This is a point that would be on the line. Okay, so it would probably be right about here. Okay, what if I had f of 0? Now I'm going to put 0 in. I guess I should kind of do it this way. Maybe it would be easier to see. Minus 4 gives me negative 4. And here's that point right there. So that's the point 0, negative 4, right? See how I got my x, and then I pulled my y. What if I said f of 1? Plug it in. Get negative 3. That would be this point right here. Okay? So then my other point would be 1 and negative 3. These are 3 points that are on that line, and I used this chart here to figure them out. Okay, how do we feel about that? Let's try, did I skip one by doing that? I guess not. Okay. I want you to try to make your own table just try number 1 from skills check 2. This is your equation right here. So set up a table. I'll help you set it up first and then have you get started. We're going to do x, and then remember we're going to do f of x. And now we know that f of x is the same as y. So that's going to equal just my 3x, okay? So you don't have to add anything. You're just going to plug them in. Pick 3 numbers. I don't care what numbers you pick. If I were you, I'd pick some easy numbers. 1, 0, -1. You want to have 3 values along your point somewhere. So pause this video and let's check them together. All right, how did you do? Let's. Now yours might be different than mine. You might pick different points. I'm going to pick 1, 2, and 3 this time, just to pick different numbers, which means f of, and now I know that x is 1, so I'm going to use f of 1, and instead of every time I see an x, I'm going to use a 1 now. So f of 1 is 3, so I have the point 1 because that was my x, and now remember f of x is the same as y, and f of x is this now. So I have a point 1, 3. F of 2 gives me 3 times 2 this time. Remember, referring back to my original equation, gives me 6. So I have the point 2, 6. And f of 3 is equal to 3 times 3. So it's 9. You might have had very different things. So all you had to do was find the 3 order pairs. You might have picked different numbers. Hopefully you picked maybe 1 or 2 of mine. This is a hard one to check because, of course, we could have different ones. All right. Well, let's keep rolling. A few more examples. You're almost there. All right. Let's keep going. Here is another table. Now, this part of the table is the same as before, and I'm just writing y to write our answer, and it'll be slightly different. It's exactly the same as our table before. I just want to show you that these are the same. Okay, I'm just going to show my work in this column, and this is the same. All right, so if we have to graph this function, this is the rule to my function. So I'm going to pick some value of x, and when I plug it in, this is my input. I put it into the rule. Every time I have x, I'll add 2 to it to figure out what y is. Now, again, just exposure. Next year, we're going to go a lot more into input and output. I wish the book did a little bit more right now, but it's just kind of a preview. Maybe, in this case, it wouldn't work, but maybe you have x being the number of motorcycles, and y is equal to the number of wheels, right? So this would not be plus, it should be 2. So if you had, for every motorcycle, you had 2 wheels, right? So if you have 5 motorcycles, you have 10 wheels. If you have 12 motorcycles, you have, 24 wheels. So you can always figure it out based on what's happening in there. So there's some sort of input. I have to put in the number of motorcycles, and it comes out with the answer of how many wheels there are. So these rules that we have are really important because they generally stand for something. We are just kind of starting basic to pick some points, kind of plug them in and see the relationship. Remember, every point on this graph is a relationship between that x and the y, and generally they stand for different things. Like the amount of money you put in, how much money you earned interest in your savings account, whatever it might be. So let's just pick some points. I like to pick some on either side of the y-axis. So let's pick -2. We'll pick 0 because that's always an easy one to plug in. Now let's pick a +2. Well, f of x is the same as x plus 2. So I'm going to plug in a -2 plus 2. You see how I pulled this x from here? Here I'm going to have 0 plus 2, taking whatever x is, and then I'm just going to add 2. 2 plus 2. Okay, now let's come put my answers in. -2 and 2 gives me 0, right? 0 plus 2 is 2, and I would have 4 here. So I have some coordinate points. I have the point when x is -2, y is 0, right? I have the point when x is 0, y is 2, and when x is 2, y is 4. So now I can plot these points, all 3 of them. So I can come to -2, 0, plot that point, come to 0, 2, plot that point in 2, 4. These are 3 points that are all on this line. Well, the whole point was to graph the line. So now you could take a straight edge and just draw a line through your 3 points. Okay, so there we go. We graphed the whole function, and this will go on forever and always. Everything on this line would make this function true. All right? Let's try another one. Let's plug in. Let's just keep with the same points. They don't have to be the same. Oops, it should be negative. Okay, here's my rule this time. My rule is going to have a few more things happening to it. Every time I'm going to multiply by negative 2, and then I'm going to subtract 5 from whatever x is. Make sense? I'm pulling that straight from here. I guess I should use my pointer here. Okay. So I'm going to put a negative 2 in. Alright, so negative 2 times a negative 2 is a positive 4. Minus 5 gives me negative 1. A negative 2 times 0, anything times 0 is 0. Minus 5 gives me minus 5. And a negative 2 times a positive 2 gives me a negative, so it's not going to fit in my graph. No, I'll just kind of show you about where we can still do this. Gives me negative 4 minus 5 gives me negative 9. So remember, the next step then is to write what are the coordinate points that you have. I'm just kind of leaving a room. I know where my line's going to go, and I've got to watch for it. All right. These are my x coordinates, and now I found what my y coordinates are by following the rule. Okay, so let's plot these points at negative 2, 1, negative 2, negative 1. At 0, negative 5. And then this is the one that I knew wasn't going to fit. So 6, 7, 8, 9. Let's just imagine that my point is right here. Okay? These are my 3 points. And then I can draw a line right down through there. Now remember, this is a line that looks like it's going downhill. And here is the function that goes with this line. All right. Let's try another one. We've got a couple different things that we're doing to it here. I'll still pick my same 3 points. They don't have to be the same. You can pick absolutely any 3 numbers. I like to pick some that will be able to go on my graph, though. So if you have a graph like this, I wouldn't pick any number bigger than 6 for a negative 6 for your x value, just so that you can put them on the graph, right? You could pick negative 5 million, and it's going to be hard to graph. So pick easy points. Make the math easy on you, too. All right. Now, what is my rule? I'm going to take whatever x is, divide it by 3, and then add 1, right? That's the rule or the function. Take whatever x is, divide by 3, add 1. Divide by 3, add 1. Okay, so I'm going to have 0 divided by 3, add 1. Oops. And 2 divided by 3 and add 1. Now this one's going to be a little bit trickier because we're not going to have some even numbers coming out. This first one here, okay, I'm going to add a couple points just to make this easier, but let's finish with this. So negative 2/3 plus 1 is actually just a 1/3. 0 to anything, 0 divided by anything is still 0, so that's just going to be 1, and this is going to be 1 2/3. Now those are going to be kind of hard points to plot, so I should have thought through this a little bit more. Think about, if I'm dividing something by 3, something might make this a little bit easier. If I pick the point negative 3 and a positive 3, I can still get some more points here. So I would have the same thing happening. Divide my x by 3 and add 1 to both of those. Remember, you could go infinitely in these. I suppose I should have written all of this in red. Okay, so what happens? Negative 3 divided by 3 gives you a negative 1 plus 1 is 0. That's an easy point to plot. And this turns into a 1, which is a negative 1, and that gives me 2. So I have a lot of points here, and I'm just going to pick the ones that are the easiest to graph when I graph them. This is when x is 0, y is 1. When x is 2, y is 1 2/3. When x is negative 3, y is 0. And when x is 3, y is, oopsies, 2. All right. So let's plot some of these easy points. I'm going to plot this one here, and this one here. Can you plot the other ones? Yes. Are they on the line? Of course they are. Are they the easiest ones? No. So work smarter, not harder. Not encouraging you to be lazy, but just make it easier on yourself. It gives you more accuracy that way too. So here's that point 0, 1. Here's the point -3, 0. And here's the point 3, 2. Okay, do I have 3 points? Do they start forming a line here? Yes, they do. And that's what my line would look like for this function rule. Okay, well, that's our last example for today. If you want to try the skills check, you can. If you want to just jump right into the homework, you can also do that. But miss you guys. I hope you're having a great day.